Hello and welcome to another exam paper walkthrough. Today I'm giving you a very different predictive paper. So I've actually come up with this predictive paper myself. I was waiting around for an additional foundation one to appear, and I thought that I would have a crack at putting one together myself. What I did was I took the Third Space Learning hot topics, so you can check out their resources, Third Space Learning. They produce quite a detailed summary of topics that have hit on paper 1 and paper 2, and they produce this kind of hit list for the foundation. And then I used Dr. Frost Maths, and I did a question search for each of the topics, and I put together questions based around those topics. Dr. Frost Maths, fantastic revision website. They produced a really good higher paper, and I hope you enjoy this foundation paper. So the Third Space of Learning broke it up into kind of 10 or so questions on each of the main areas, and I've put the paper in that order. So all of the number first, then we look at algebra, then we look at shape, and then finally probability and statistics. They're not in order of difficulty, they're just in the order that Third Space Learning created this kind of hit list. So let's crack on with question 1. Okay, question 1, round this number, so we're looking at rounding, correct 2 decimal places. So the second decimal place here is a 3, so we round into that figure, so we're looking at 2.74. Okay, question 2. Tulips cost 85p each. Sarah has £20 to spend on tulips. She buys the greatest possible number of tulips. Sarah pays for £20 note. Work out how much change she should get. Okay, so we're going to bring in our calculator for this. Okay, so I want to do £20, or I could convert. I've got a mixture of units. I've got pence and pounds, so I could either convert that into 2,000 pence, or I can convert this into pounds. So I'm going to convert this into pounds. So I'm going to do 20 divided by 0.85. So that's going to give me so I've mistyped completely there. Let's look at that again. So it should have been 20 divided by 0.8. So as a decimal, actually I want this as a mixed fraction just to make that helpful for me. So I'm looking at 23 and 9/7. So I want to work out how much, if she pays for a £20 note, work out how much change she would get. So in effect, what I want to work out is I want to do 20 take away 23 times by 0.85. And that'll give me the change. So 20 minus 23 times by 0.85 gives me 0.45. So how much change would she get? She would get 45 pence. Okay, question 3. Express 45 as a percentage of 129, giving your answer correct to the nearest whole number. So I'm going to go 54 divided by 129 times by 100. And that should automatically give me my answer, so I'll type it in like that. So 54 over my fraction twice, over 129, and then multiply that by 100. That's going to give me 41.860. So, and I want that to the nearest whole number, so that's going to be 42%. And question 4, write brackets in the following calculation to make the answer correct. So I need to kind of figure out where these are going to go. Good tip on a calculator paper for this is you can actually type it in. So currently it equals 38, so that's not going to work. So I've got various options of where I could put the brackets. and round here I think is going to work, because 6 minus 3 is 3, and then that would create 2, so let's just double check. So could literally go through the process of putting them in wherever, but yeah, that would work perfectly. So I'm going to go around here and around here. Okay, question 5. Maria is going to make blackcurrant pies. Here is a list of ingredients to make 6 blackcurrant pies. Maria has the following ingredients. Work out the greatest number of blackcurrant pies she can make using her ingredients. So I'm going to kind of look at the batches for this. So if I look at flour first of all, for flour she can make, she's got 755 grams and she needs 150 for the recipe. So she can make 755 divided by 150 gives me 5.03 reoccurring. So that's the number of batches you can make with flour. And then I'm going to do the same with the other ingredients. So blackcurrant. So she's got 1,265. She needs 420 for one batch. So she's got enough for 3.011. So I'm going to leave that like that for now. So that's going to be my, so actually I'll remove that symbol there, dot dot dot. So that's our limiting factor at the moment. If we then look at sugar, so for sugar she has got 685, and for each recipe she needs 170. So 685 divided by 170 gives me 4.029 dot dot dot. So it's our blackcurrant that's our limiting factor. And then finally, if I look at butter, so we've got 950 grams of butter, and for each recipe we only need 95 grams, so she's got enough for 10 batches using that. So our limiting factor here is the blackcurrant. So in effect we need to times the blackcurrant aspect by 6. So let's go back to this exactly. 1265 divided by 420. Realistically, I think 3 would be absolutely fine to use at this point. I just like to get the exact value. So that times by 6, and that gives me 18. So even if I'd have done 6 times 3, I would have still got 18. So I'm going to say 3.0119 dot 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 times by 6 is equal to 18.07 dot dot dot. So she can make 18. Okay, question 6. Write 0.6 as a percentage. 0.6 as a percentage then. So that's going to be equal to 6 over 10, which is going to be equal to 60%. Right, question 7. Work out giving your answer in its simplest form. So we're using a calculator for this, so I'm going to use my calculator. So to type in a mixed fraction on your calculator, you are going to have to press Shift and then the fraction button, and then you type in your mixed fraction just like that. From that I need to subtract 1 2/3. So if that's asked on a calculator paper, you let your calculator do the work. Giving your answer in its simplest form, I want that actually as a mixed fraction because that's the format that's in the question. So Shift and then SD will convert that into a mixed fraction for me. So I'm looking at 1 11/15. Let's try and draw my 15 a bit better. Right, question 8 then. So the pictogram shows information about the number of cans of cola sold in the shop on each of 6 days. Find the ratio of the number of cans of cola sold on Thursday to the number of cans of cola sold on Wednesday, given your ratio in its simplest form. So we're looking at Thursday's total, Tuesday's total versus Wednesday's total. So I'm going to put that in. Right. Each symbol represents 10 coins, 10 cans of cola. So on Tuesday there were 1, 2, 3, 4, 5, 6, 7, 8, 9. So that in effect is 9 times 10. And on Wednesday we've got 1, 2, 3, 4, 5, 6. So if I don't need to do that multiplication because we're after the ratio in its simplest form. So that's I could have just done it in terms of pictures. I was expecting a kind of a partial, but that's okay. And then we simplify that down. Both of them have got 3 in common, or we can use our calculator to simplify it down. So if you imagine it, I tend to put the lower of the 2 ratios, so 3 to 2. Right, question 9. Work out, so we've got standard form calculation. We can use our calculator for that. So type the first one in, put it in brackets, 2.3 times by 10 to the 4. And I want to times that by, next one in standard form, 6.7 times 10 to the 3. And I want to divide that by 5 times 10 to the minus 8. So there we go, and that's automatically in standard form for me. So I'm looking at 3.082 times by 10 to the 15. Okay, question 10. Fountain A squirts water every 24 minutes and Fountain B squirts water every 42 minutes. They squirt water together at 15:19. Find the next time they squirt water together. So I want to find the lowest common multiple of these 2 numbers to start with. And on a calculator paper, I kind of do a little bit of a cheaty method or a shorthand method to find my highest common factor. What I tend to do is I will cancel the fraction down, treat the 2 numbers as a fraction, cancel them down, and then the highest common factor can be found, lowest common multiple. The lowest common multiple can be found by either doing 24 times 7, so the numerator 1 times the denominator of the other, or the other way around. So I'm going to do 24 times by 7, which is going to give me 168. And we'll just double check that. 42 times by 4 should also give us that. It does, yeah. So that's our lowest common multiple. So what we want to do is now we're looking at time. So if I'm starting at 15 hours and 19 minutes and I want to add on 168 minutes, my calculator will do that for me. So I type 15 hours, 19 minutes, and I missed my time function off there. So that enters it as a time, and to that I want to add on 0 hours and 168 minutes, and that tells me that the time is going to be equal to 18 hours and 7 minutes. So that's my time, 18:07. Right, question 11. Students at a school must choose one subject from option 1 and one from option 2. The school offers 2 languages, French and Spanish. The subjects are given in the table below. So we've got, work out the percentage of all the subject combination which have exactly one language. So if we start by looking at our options, so I'm going to call F, A, M, and E. And then I've got S, G, and H. So my options are, I can have F and S, F and G, F and H. I can then do the same combination starting with A. And they're going to have the same combination with M. And then finally, same combination with E. Right, work out the percentage of all the subject combinations which have exactly one language. So exactly one language, I'm going to what I'm going to do is I'm actually going to cross out the ones that have more, either don't have a language or have more than one language. So all of this column except for this one have exactly one language. All of this column have exactly one language, and then no, sorry. So these ones don't have one language, and then these ones don't have one language. So I'm looking at, just double checking in my head, Spanish, 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 French, French. So those are my combinations. So I've got 1, 2, 3, 4, 5 out of the number of combinations. So I've got 4, 8, 12, and I want to times that by 100 to get it as a percentage. So on my calculator, I'm going to do 5 out of 12 times by 100. That gives me 41.6%. Well, it's 41.6 reoccurring percent, so I'm going to go, let's go 42%. Okay, question 12. Make D the subject. So making D the subject means I want to have it as, in the end, D is equal to. So I need to get rid of the times by 7 on the D, so I'm going to divide by 7 on both sides. That gives me C over 7 is equal to D, so D is going to be equal to C divided by 7. And question 13, expand. So I'm going to multiply each term, the term outside the bracket by each term inside the bracket. So 5 times by 2g would give me 10g, and then 5 times by 7 would give me 35. Okay, so we're looking at laws of indices here. So when we multiply powers, when we multiply indices, we add the powers. So that's going to become k to the power 6. Okay, question 15, expand and simplify. So we're going to times, so I tend to use the construction line. There's nothing wrong with using the grid though. I'll do both methods here. So x times by x would give me x squared. X times by 3 would give me 3x. Then I'm timesing everything by 2, so 2 times x would give me 2x. And then 2 times by 3 would give me 6. So that's how I would expand it using construction lines. Using the grid though, that's absolutely fine. You kind of end up with almost the same thing. So x plus 2, and then x and a 3 plus 3 there. So when I expand that, x times x gives me x squared, x times 2 gives me 2x, x times 3 would give me 3x, and then 3 times by 2 would give me 6. And then when I simplify either of them, I simplify the middle terms, or these two terms. Well, these two terms. So that gives me x squared plus 5x plus 6. Okay, question 16, factorise fully. So I'll do this part by part. So our highest common factor of 8 and 6 is going to be 2. We've also got an x in common, and we've also got a y in common. So I can take 2xy out as my common factor, and then what do I need to times 2xy by to get 8x squared y? That would be 4x. And then what do I need to times 2xy by to get 6xy squared? That would be 3y, with a plus sign in the middle, and close my bracket off. There we go. Okay, question 17, we're looking at factorise. So that's going to go into 2 brackets. Actually, we'll do it over here. I'm looking for both brackets to start with an x, because that's the only way I can make an x squared. And then I'm looking for 2 numbers that multiply together to make the back number, which is minus 24. And that add together to make the middle number, which is 2. So That automatically tells me that one number has to be negative and that the larger of the two numbers is the positive one. So if I think about factors of 24, 6 and 4 are the ones that jump to mind because they have a difference of 2. So it's going to be 6 and minus 4. So my bracket's going to be plus 6 and minus 4. Okay, question 18. Draw the graph of y is equal to 2x minus 6. So we've got quite a few ways that we could do this. We could do this straight from principles and say that the gradient of this graph is going to be 2. And the intercept on the y-axis is going to be minus 6. So we could draw it straight from the properties. Or alternatively, we could draw it from a table of values. We can use our calculator for the table of values. So the function that I'm looking at is 2 alpha x minus 6. I want to start at minus 1, so I don't need a second function. I want to start at minus 1. I want to go up to 5. And I want to go in steps of 1, so that's my table of values. So when minus 1, we would have minus 8, and then so on, all the way up to, well, I'll do a couple more. Let's go 1 and minus 4, and then the last one. 5 and 4. And I'm actually going to use properties though. So we're going to start at minus 6. This is graph. We've got, it's going down to minus 5, so that would be minus 6. And then for every 1 across, it's going to go up 2. 1 across, up 2. 1 across, up 2. 1 across, up 2. 1 across, up 2. 1 back, down 2. And then we can see that these points actually line up. So we've got minus 1 and minus 8. That's the one that we particularly looked at from our table. 1 and minus 4. And 5 and 4. Final step is to join them up with a straight line. So and there we go, that covers the whole range. Okay, question 19. Here is the graph of y is equal to x squared minus 2x minus 1. Use the graph to solve the equation x squared minus 2x minus 1 is equal to 2. So this is quite a difficult one on the foundation, but Third Space Learning quoted it as simple, no, let me sort it out. Quadratic graphs including estimating solutions. So this is an estimating solutions. So what I'm going to do is I am going to draw the line. Well, if I compare this with the equation that I started with, so this is the equation of y is equal to x squared minus 2x minus 1. So the difference here is y and 2. So I want to draw the line of y is equal to 2. So that's going to be this line here. Let me just put that in neater. Okay, and then my estimate is just where they intersect. So they intersect there and there. So the solutions are when x is equal to minus 1 or x is equal to 3. Okay, question 20. Here is a term-to-term rule for a sequence. Multiply the previous term by 2 and then subtract 3. The third term of the sequence is 31. Work out the first term. So we want to work back to the first term. So we'll need to work out the second term and then the third term. So we're starting with the third term of 31. In effect, we've got a function machine. Well, we can view it as a function machine. So the functions are multiply by 2 and then add 3. Sorry, and then subtract 3. So if I'm going in reverse, So I'm going to have to do the opposite. So add 3, which would be 34, and then divide by 2, which would be 17. Then if I go in reverse again, add 3 is 20, divide by 2 would be 10. So I'm kind of going the opposite way. So my first term would have been 10. Okay, so 21. Here is a number machine. Find the output when the input is -7. So if I put -7 in, -7 times by 5 would give me -35. And then -35 plus 20 would give me -15. So I'm looking at -15. Okay, question 22. Calculate the perimeter of the quarter of a circle, given your answer correct to 1 decimal place. Well, the perimeter of a circle, the circumference of a circle is going to be equal to 2 pi r. And we want to find a quarter of that. So the perimeter of the arc is going to be equal to 2 pi r divided by 4, because we want a quarter of it, which is the same as pi r divided by 2. So pi times by 9 divided by 2. And I'm not going to go to my calculator just yet. So we want the perimeter though, so that would just be the arc length. Pi times by 9 divided by 2, but we want to add on that length and that length. So we want to add on an additional 2 lots of 9. So the perimeter is going to be equal to pi times by 9 divided by 2 plus 18. And as a decimal, that's going to give me, let's go back into normal function. So shift pi times by 9, and I want to divide that by 2. And then I want to add on 18. So that's going to give me 32.137 ... So I haven't rounded yet. So that's going to be 32.1 centimeters. And question 23. So ABC is a triangle, and we've given some lengths, the angle and 2 angles. But so we're looking at a right angle triangle. We want to work out the length of BC, so I'm going to call that X for now. So this is right angle triangle is either going to be Pythagoras or trigonometry. If we look at what information in the question, we're dealing with 2 sides and an angle, so we're going to be using trigonometry. So my first step is I'm going to label the 2 sides that I'm working with. So this 7.9 would be the hypotenuse, and this X would be the adjacent. So I'm looking for my trig ratio that involves a H and an A. It's going to be the cos ratio. And I'm trying to work out the adjacent, so it's going to be the adjacent is going to be equal to cos of the angle times by the hypotenuse. So let's substitute in then. X is going to be equal to the cos of 38 multiplied by the hypotenuse, 7.9. So my calculator gives me cos of 38 multiplied, this is why the brackets are important, multiplied by 7.9. So that gives me 6.222 528 ... So I've not rounded, and then 3 significant figures, 1, 2, 3. So I'm rounding to that figure there. The number behind it is a 5, so it becomes 6.23 centimeters. Okay, question 24. Find the size of the angle marked with C. So for this question, we're using angles in a triangle need to add up to 180. So C is going to be equal to 180 minus the 2 angles. So minus 78 minus 33. So that's going to be 180 minus 78 minus 33. So check 78, 33. So we're looking at 69 there. So 69 degrees. Okay, question 25. So looks like a bearings question. So the bearing of B from A is 62 degrees, or 062, which is shown. C is due south of B, and we're told that AB is equal to CB. So we've got, in effect, an isosceles triangle here. Calculate the size of angle X. So I'm not really going to use the fact that it's an isosceles triangle. What I'm going to use is the fact that we've got a supplementary angle here. So if that's a supplementary angle, then 180 minus 62 is going to be equal to 118. And then angles along a straight line. Actually, I didn't need to use that it was a supplementary angle. It's not wrong, but we've actually got an alternate angle. So it's going to be equal to 62. Because it's an alternate angle. Okay, 26. Work out the exterior angle of a polygon with 8 sides. Well, the exterior angle of any shape is always going to be equal to 360 divided by the number of sides. So 360 divided by 8 in this case. So 360 divided by 8 is going to give me 45 degrees. Okay, question 27. This diagram shows the position of a yacht Y, a ship S, and a beacon B. The bearing of B from Y is 228 degrees, and the bearing of S from Y is 118. Given also that BY is equal to SY, find the bearing of S from B. Okay. So we actually want this angle here. But how we're going to go about that is like this. We're going to say that the bearing, I'm going to put in some information. So this angle here is 118. This angle here is going to be 228 minus 118, so that's going to be 110. And then I'm going to go slightly further, and I'm going to say what this angle here is, because I'm going to use that shortly. So I'm going to do 360. I can actually show what I'm typing in. 360 minus 228. So that's going to be 360 minus 228 is going to give me 132. Right, and then I'm going to work out the size of this. This is an isosceles triangle, so these angles will be equal. So I'm going to say that this angle here, so I'm going to call that YBS, is going to be equal to 180 minus 110 divided by 2. Because angles in a triangle equal 180 and base angles of an isosceles triangle are equal. So that angle there is going to be 35. And then I need finally to work out this angle here. This angle here and this angle here create a supplementary angle. I knew there was a supplementary angle part to this paper. Minus 132 is going to be equal to 180 minus 132. It's going to give me 45, 48 even. So the angle, the bearing of S from B is going to be equal to these two added together. So it's going to be equal to, so S from B is going to be equal to 48 plus 35. so 83. And then as a bearing, bearings are always quoted as 3 figures from the north direction, so that's going to be 083 as a bearing. Okay, question 28 then. So describe fully the single transformation that maps P onto shape Q. So P onto Q. So if we look at the orientation, first of all, it's been rotated clockwise 90 degrees. So the transformation is a rotation. And the amount is 90 degrees clockwise. And then the point of rotation is the final bit that I need to work out. So can use tracer paper for this if you struggle to spot it. So if I imagined it was the origin, so that point there is currently 2 to the right, 1 up, so that would go 2 down and 1 to the left. Sorry, 2 to the right and 1 up would become 2 down and 1 to the right, so that would work. So about the origin, or about the point 0, 0. Right, question 29. On the grid, translate the shape P by the vector of -5, 2. So I pick a point that I'm going to look at moving. So the shape's orientation and size won't change, just the positioning. So I'm going to go -5, so that means 5 to the right, left, and then 2 up. So that point is going to go 2, 4, 5 up across, and 2 up. So that's going to go to there. So I should have probably included a little bit more on that. So let's just double check that. So 2, 4, 5, and then 2 up. So just hitting the top of the axes there. And then I just recreate that shape. So I'm going from there, I go 2 down, 1 across, 1 down, 2 across, 3 up. So that's going to be my translation. Okay, question 30. Someone wants to create a space for a water play in the village hall. He has this diagram on the floor, so we've got the diagram 4 times. The space for the water must be in the shape of a rectangle 3.5 meters by 4 meters, at least 2 meters from any other activity space, at least 3 meters away from the door. So we're given a key here. 1 square length on the grid represents 1 meter in the village hall. And we've got the activity space, and we've got the lines representing doors. Circle all the correct answers from the diagram below. So if we think about this first of all, in the shape of a 3.5 meter by 4 meter. So we're going to kind of use this as a checklist. So are all these rectangles 3.5 by 4? So 3.5 by 4, yes, A is. 3.5 by 4, yes, B is. This one is 4 by 3.5, so yeah, it still fits the dimensions, and then 3.5 by 4. So all of them fit that first criteria. Second one, at least 2 meters away from other activity spaces. So A definitely is. B is actually exactly, which does still fit the criteria, at least. C is just over 2 meters, and D is bang on 2 meters. That corner would be exactly 2 meters away from the slide, so they all fit that criteria. The final one, at least 3 meters from any door. So let's just highlight the door again. So that's the door. This one is not within 3 meters, so it can't be A, because we've got 2.5 meters away from the door in A. For this one does fit, so B is definitely an option. C, at least 3 meters, so we're just over 3 meters here, so C would work. And then D is 1 meter away, so definitely not D. So our answer is B and C. Okay, question 31. Here are some triangles on a grid. Two of the triangles are congruent. Select the two triangles that are congruent. So congruent means same size and shape. Same size and shape. So if we're looking for if we just look, congruent means same size and shape. So which ones are the same size and shape? So that would be A and F. Those are the only two that are the same size and shape. So A and F. Okay, question 32. Which two units are sensible to measure the distance between two towns? Between two towns, so let's think about this. So centimetres, definitely not. Meters, I don't think meters is necessarily a good one. If I think about two towns, let's say Wolverhampton and Dudley, meters wouldn't be a very appropriate one. Kilometres would be, inches wouldn't be, and miles would be. So I'm going to go kilometres and miles. Okay, so I've done something slightly different here. When I was looking at this, this was meant to be, so the third space learning asked us to do speed problems solving, so solving a speed problem, and I use this, and it's not really a very good example at all. So I've kind of come up with my own question very quickly, just to make sure you have a bit of practice on what it could potentially be. So what I've said is, if two towns are 9 miles apart, town A and town B are 9 miles apart, and a car travels and it takes 2 hours to get between those two towns. And towns C and D are 10 kilometres apart, and it takes 1 hour and 30 minutes to travel between them. And then the question that I'm posing is, which journey has the greatest speed? So that would be more relevant to the speed problem solving. So the way that I would approach this, so feel free to pause the video and have a go at this question before I go over it. I just want to make sure you've got the best opportunity in terms of question coverage. So the way that I'm going to do this is I'm going to say that the speed speed is equal to distance divided by time. So for AB, the speed between A and B is going to be equal to the distance, which is 9, divided by the time, which is 2. So the speed is going to be 4.5 miles per hour. What I've also given you here is the conversion that 1 mile is equal to, I should have put mile, 1 mile is equal to 1.6 kilometres. So for C to D, we've got a difference of units. So for C to D, speed is going to be equal to the distance, and I want to convert the distance. So to convert the distance, I would have to do 10 times by 1.6, and then I'm going to divide that, and I'm going to use the time function on my calculator to convert 1. Well, no, I won't. 1.5 hours, 1.5. So if I do that on my calculator, I'm going to look at 10 multiplied by 1.6, and I want to divide that by 1.5. So that's going to have a speed of 10.6. So not necessarily the best, not very close. So that's 10.6 reoccurring. So which one has the greatest speed? So the one that has the greatest speed is C to D. There we go. I thought I'd set that up better. So I've converted wrong. What I should have done here is divide. So apologies. Sorry if you're screaming at the screen at the moment. So I should have done 10 divided by 1.6 divided by 1.5. In my head, I thought that I'd picked slightly closer numbers. That should have been a divide though. So there we go. what I was hoping for. So 4.16 miles per hour. So that's going to be 4.16 miles per hour. So which speed is better? So A to B would be faster. I hope that makes sense. I just wanted to give you a little bit of an idea of the type of question, because that wasn't really fitting very well. Okay, question 33. So a shaded shape is shown on the grid. On the grid, enlarge shape B by a scale factor of 2 about the indicated centre. So this is my indicated centre. So if I look at a specific point, and that's the only one that I'm going to actually look at moving in this way, my shape's going to be twice as big, but where I start drawing it from is going to be what I work out here. So currently this is 2 squares across and 1 square up. So if I double that distance, it's going to become 4 squares across and 2 squares up. And then I'm going to just enlarge the shape by a scale factor of 2. So instead of being 4 up, I'm going to go 8. So instead of being 3 up, sorry, I'm going to go 6 up. So 3, 6 up. And instead of being 2 across, it's going to go 4 across. So that's going to be my shape. Okay, question 34. A box contains a number of packets of crisps of different flavours. A packet of crisps is taken at random from the box. Some of the probabilities of taking each flavour are shown in the table below. Calculate the probability that the crisps are bacon flavoured. So that's our only missing probability. So we need to add up the other ones. So if I say I'm going to do 0.3 plus 0.12 plus 0.25 plus 0.05. So they currently add up to 0.3 plus 0.12 plus 0.25 plus 0.05. That adds up to 0.72. So the bacon must be 1 minus that, which is going to be 0.28. And taking that topic a little bit further, because it's supposed to hit relative frequency of mutually exclusive events. So we've just worked out the probability. If how many times would you expect bacon? If 200 people, sorry, let me just read the question again. Okay, so if we took 50 crisps from the box, how many times would you expect it to be bacon? So if we did it 50 times, how many times would you expect it to be bacon? You'd times 50 times by the probability that we just worked out. So that would be 14. Not relevant to this question, but just covering you a little bit deeper in case they ask a kind of a slightly more detailed question. Okay, question 35. There are some cubes in 2 boxes. There is a number on each cube. Steph plays a game with the cubes. She takes at random a cube from each box. She adds the 2 numbers on the cubes to get her score. Steph wins the game if she gets a total of 10. Work out the probability that she wins the game on her first attempt. So if we think about the options, we could have a 2 and a 1, 2 and a 2 and a 1, a 2 and a 4, a 2 and a 5, or a 2 and a 7. We could then have a 3 and a 1, a 3 and a 4, a 3 and a 5, a 3 and a 7. We could then have a 6 and a 1, a 6 and a 4, a 6 and a 5, and a 6 and a 7. So Steph wins the game if she gets a score of 10. So which one is the scores of 10? So we've got a score of 10 there, and we've got a score of 10 there. So what's the probability that she wins the game on her first attempt? Well, we've got 2 out of the number of outcomes, and we've got 3, 6, 9, 12 outcomes. So it would be 2 out of 12, which is going to be the same as 1 out of 6. Okay, question 26 then. So the graph shows the speed of a car during 30 seconds of its journey. Find the total distance travelled by the car in the 30 seconds. So on a speed time graph, the area of the graph is going to be equal to the distance. Because if you think about it, speed, we've got speed on one, which is in meters per second, and then we've got time in seconds. So if you times them together, the seconds kind of cancel out and you're left with just the distance. So we want the area under the curve. So we want a triangle and a rectangle. So the area is going to be equal to, or we could treat it as a trapezium if we wanted to. I'm just going to treat it as a triangle and a rectangle though. So the area of the triangle is going to be a half of 8 times by 18. And the area of the rectangle is going to be 30 minus 8 is going to be 22 times by 18. So use our calculator for that. So I'm looking at 468 meters. Okay, question 27. 30 students were asked to draw a circle or a square and to colour it in. Here are the results. So we've got circle or square, red, blue or green. How many squares were drawn all together? So squares all together is going to be the total of this one. So we're looking at 6 plus 3 plus 2. So that's going to be 11. Okay, question 38. Eliza throws a 4-sided dice numbered -1, -2, -3, -4 and a 6-sided dice at the same time and finds the difference between their scores. So find the probability that Eliza gets a difference which is 10 or less. Okay, so 10 or less. So all of them. So we've got 24 out of 24. So that's just going to be 1. Certain. Probably not the best question selection there from me. I do apologise. Let's just also cover difference of probability of her picking a number with a difference of 6. So a difference of 6. So if I were looking at a difference of 6, I've got 1, 2, 3, 4. So that would be 4 out of 24. Which would be 1 out of 6. Just covering a little bit of a deeper question. Okay. Apologies about that. I'm just going to run through that question again. I think I messed up on my recording of it. It's a frequency table of the pictogram. It illustrates information about the number of letters received during the office in 1 week. So we've got partial pictogram, partial frequency table. There's a total of 145 letters are received in the week. Complete both the frequency table and the pictogram for Thursday. So the first thing that the pictogram is missing really is going to be the key. So the key is going to help us anyway. I'm not sure whether we'll pick up a mark for it, but if we look at the total for Wednesday and the total for Friday, we can see that we've got 2 envelopes representing 20 and 1.5 envelope representing 15. So each envelope represents 10 people or 10 letters received. So for Monday, we've got 1, 2, We've got 1, 2, 3, 4, 5 envelopes, so that's going to represent 50 people. And from there, what we can do is we can say that the total number of envelopes received so far is 50 plus 25 plus 20 plus 15, which you can see I've just done on my calculator already, is going to be 110. So we know that 110 have been received. So the missing value for Thursday is going to be 145 minus 110, which gives us 35. So 35 is going to go there. So following on from that, we can draw that. We can draw Thursday's total as 3 full envelopes, 2, 3, and half an envelope, which I'm going to draw like half a square with a V in it. And there we go. And that brings us to the end of the questions. So, having written it myself, there's a couple of aspects. There's 3 questions in particular I didn't think covered the topic from the hit list particularly as well as it should have. So I've gone into a bit more detail on those questions. I'll put that in the link as well. Hope you found that useful. Again, a reminder then, so this was all based around the third space learning hit list for GCSE for the foundation revision focus list. Broken down by the numbers, by the areas, number, algebra, shape, probability and statistics. I hope you found that useful. Please feel free to tick and cross how you feel you are on those topics. That might help you target your last minute revision. And I hope you found that video useful. If you have, please subscribe if you like. And all the best for Wednesday. I know we're last bit of revision now. Good luck for that. I hope you get exactly what you want, if not better. Thanks again, and see you soon.